Hey class, and welcome back to lab number 4, where we're going to investigate uniform circular motion, centripetal force, and gravity a little bit more. So lab 4 is broken into 3 parts, A, B, and C. For part A, you're going to need a piece of PVC pipe or tubing or something. This one here is about 10 or 12 inches long, something like that's fine. It could be a little shorter, a little longer. You'll want some sort of string or fishing line. So I have about 1 meter of fishing line that runs through here. And then you're going to need a couple masses. So again, I just found a little nut that I tied on a string on each side. So I have a smaller nut on one side, a larger nut on the other side. And I'm using fishing line because it's stronger. You can use string or something like that, but just be real careful. The string might be more likely to break. And you want to try to have the inside edge of your tube be as soft as possible, because ultimately what you're going to be doing is you're going to be taking this and you're going to be spinning the mass around like so, letting go, and you'll see that it balances perfectly. If I start to spin slower, you'll see this mass actually moves inward, and if I spin faster, it moves outward. But you got to be real careful. Make sure you don't hit yourself with this. And you're going to be spinning it and shooting for different lengths of this string up here. And so if you notice, it might be hard to see, but I actually marked my string with little black marks, various different spots, in order to show me the target lengths I'm going for. So you're going to be spinning it and trying to get it at various different lengths, and then trying to determine the period, the amount of time it takes to complete one revolution. So you're going to be measuring that, and you're going to want to do it over various rotations. So like say you swing it around and you count that you swing it for 20 times, and if you take the amount of time it takes for those 20 cycles, your period is going to be that time divided by the 20 cycles, because a period is just the amount of time for a single cycle. So the first part is, again, just using this sort of setup. You can actually see in the lab, it's showing you there's a smaller mass M1, the larger mass M2, tied to either end of a fishing rod or fishing line, and you're going to be spinning it around as this pre-lab question kind of talked to you about up here. So this is the idea of what you're going to be doing as I try to show you. So that's for the first part. Second part, part B, is looking at dropping objects in a gravitational field. This one you're going to have some freedom to choose. I want you to drop 5 different things that are likely to have different accelerations due to gravity. And so I want different objects of different sizes, different shapes, different densities, and so on. So I just grabbed some different things. I got a tennis ball here. I found a Nerf dart. I can drop that. I got this little like toy cube here. I got a larger, more solid ball that's a toy that my dog bats around. It's actually, I think, a horse toy, and we drilled a hole in it. We put treats in here. He kicks it around and the treats fall out. I got this like a coffee filter, so it's a light piece of paper. Found an empty soda can, or even like a plastic egg. You can put different weights in here to make it fall at different rates. And so those are just some examples, but you're going to choose different things, drop it from a certain height, measure the time it takes to fall. Pretty straightforward there. And then for the last part, sometimes people get confused about part C and what's going on. You're investigating the inverse square law, which gravity, the force due to gravity, is an example of an inverse square law because it decreases with 1 over r squared, r being the distance your thing is away. Well, the intensity of light is also an inverse square law. So what you're going to be doing is you're going to be taking some sort of a cup or a piece of paper or something. So I have like a cup right here. Okay, I put a little hole in it. You want this as round as possible, but I didn't do an amazing job of making it perfectly circular. Okay, and so then what you can do is you can either take this and put it on the end of a cup, or you can even take it and just use your cell phone and the light on your cell phone as well. Because what happens is, I'm going to try to show you this in a minute. I'm going to dim the lights and show you here on the wall. So I'm going to pause. So if you check this out, right, if I take my light from my cell phone and just shine it at the wall, I mean, if I get really close, you can almost see sort of a circle. As I get further away, it gets really dispersed. But check it out. If I take my cup and put it with the light coming out of that little hole, now I get a very nice set circle of light as I move backwards. And I can actually measure the area of that. So here's a situation. Again, it'd be really helpful if you have a friend or a way to kind of balance your phone or something. But if you get it set up just right here, you can actually measure the size of that circle. So you could, get somebody to hold your phone for you like this, or even just use one hand, and then take just a little piece of tape, put it at the center of the circle, a little piece of tape at the edge, and then you can measure the radius to find the area. You can do it with a cell phone light, as you see here, or you can get a flashlight, attach it to the end, and you get the same basic idea. And as you move back, it gets bigger and bigger, keeping that circular shape. And so you're going to be measuring the size, the area of this as it goes backwards and see how it changes with distance. So it's a cool little way to experimentally look at the inverse square law. Try to use a styrofoam cup if you have one. If you don't, you can also use like a piece of paper and basically make it into a little funnel so that the end is nice and circular and you're just sort of forming the light into a nice shape. Okay, so that's kind of what you're doing. And I included some pictures on here to try to help you see kind of the setup, either using a phone or a flashlight, and then you're going to be recording the area of that light circle and approximating its intensity as well. All right, so that's pretty much what you're doing for Lab 4.